Next speaker is Mark Wolcott. He has served the transportation industry, the public sector, for the last 35 years with Maryland's Maintenance and Materials Technology Office. Currently runs a small veteran-owned business called that he formed in 2016 called iSee. iSee focuses on NDT testing of bridge decks, bridge approaches, and other highway assets. So without further ado, Mark Wolcott.
I want to thank the committee for selecting my presentation on non-destructive testing that we've been doing for 6 years now in Maryland. And I'm just going to briefly go over a little bit about my company before I get into the approach slab discussion. I'm the president of the small business, a veteran-owned small business. I had the honor of serving our military and mainly in the Maryland Army National Guard. I also have worked in the Northeast, but primarily in Maryland, Pennsylvania, New York, and New Jersey with this small business. I'm able to mobilize to these states within 24 hours for any emergencies. And I'm a prior state employee at Maryland State Highway Administration, where I was very active in responding to emergencies as the Deputy Director of Materials Engineering, and we had responsibility for all the sinkhole responses and pavement investigations, network asset investigations. So I have 36 years in the industry. 6 years of that experience is with the step frequency ground penetrating radar. And everything that my whole philosophy is partnerships. So I've worked on these different agencies and partnered with a number of large engineering firms as a veteran-owned small business and a small business in Maryland and surrounding states. So I'm sure a number of these are here today, and I thank you for involving me in your project. So what is ground penetrating radar? It's basically sending an electromagnetic wave, reflecting it off different materials with dielectric properties into the ground. The traditional one shown here is an impulse radar, mainly used, in my experience, with pavement thickness that we coupled it with falling weight deflectometer testing in the state of Maryland. But the step frequency portion of ground penetrating radar is, like a lot of things, technologies come developed by the Department of Defense, and they used it for finding IDEs in military convoys and movements. So now the step frequency portion is taking the electromagnetic waves over a number of frequencies, which are 150 megahertz to 3 gigahertz for the antenna system that I currently operate. And that's basically equivalent to 7 impulse GPR antenna pairs. Here's the transmitter and receiver kind of diagram showing that you're basically getting a full scan of your features, whether it be a bridge deck, pavements, or ground cover. Maryland State Highway, we were searching for a way to get people off the bridge decks, a little less time on the bridge decks inspecting, and the responsibility of the Office of Materials Technology was to take bridges that were assessed by Office of Structures and do detailed studies. So we started in 2014 this air-coupled antenna with Schnabel Engineering to investigate a couple of bridges in Maryland. And we did a research study with the University of Maryland and settled on this ground-coupled step frequency GPR antenna made by 3D radar. Fast forward to 2019 when I had left State Highway and purchased the equipment, and here's the ground-coupled system that iSee operates. Basically operates at 12 to 20 miles an hour, scanning the bridge decks, and you can notice here on the surface, the ground-coupled antenna. It's about 2 inches off the ground, and it's on a lift system, so as soon as you cross the bridge, then you can either move on to the next bridge or the approach slab, or you can then lift it and back up and do another scan in that lane. It's very flexible. Here's the typical setup with a TMA shadowing the operation, but again, it's all vehicle oriented. A typical project is scanning bridges within a corridor. So here's one down in Maryland, and you can see in red what we collected in one night shift of the bridge decks in this area. Here's a more difficult bridge to do testing on, Urban Diamond. And here's a picture with the GPS using survey grade surveys of where we collected to get this done in a couple of hours. Also, again, working with other firms with expertise, partnerships is the way my firm gets things done. Nexco West, who has a booth here, Earth Tone, who is also here, Infrasense is also here. I'm not sure Schnabel has a booth, but SIVA Corrosion Services, and Synergies 360 and Contour, which used to be 3D Radar, is the manufacturer of the antenna and provides significant resources both for hardware and the software. iSee does the collection, and all these partnerships are needed to do the processing of the data. And then I do the project management with those larger firms. So the bridge evaluation I'm going to be talking about today with the bridge approaches was performed by Nexco West, and they have 7 years of experience with step frequency GPR and 20 years of experience with infrared thermography. They were, Nexco, for a little bit of their history, had established in Japan and has been in the US since 2011, and have, again, 7 years working with GPR, 4 years with pavement evaluations, and 20 with visual and infrared technologies. So this is basically a typical output of a concrete pavement and what you would see if you peeled off the pavement of the subsurface conditions with moisture and voids below the pavement. Here's just a little diagram showing the void or the soft areas that may be filled with water during periodic storm events. So here's another scan. Again, you can take the ground penetrating radar, and it's a 3D model. You can slice it at any depth into what you're penetrating. And this one is backing off. Instead of peeling away all the pavement, you're stopping right at the bottom of the pavement, and you can see the heat map showing different colors of where the thicknesses of the concrete pavement meet the approach slab. You could also add the bridge deck, but that was not part of this particular project. Here's just a blow up of just the approach slabs, and you can see the different thicknesses. And then you always want to compare this to your historical information. Here we had the diagram from the as-built. We also had the pavement history and other borings in the area that were done previous to the scans. Borings are very typical for investigating subsurface investigations, but they are a point of information where the 3D radar or the step frequency GPR has a continuous and 3D imagery. Here's just a blow up now looking deeper below the pavement, and again you can see where the issue is, water running off the bridge deck across the concrete slab, approach slab, and then is finding its way into the joint where the approach slab and the concrete pavement meet and have created a void. And if I had the imagery here, you can see where they've patched this area from loss of subgrade strength. And we've developed with the client on this one a grouting contract to make repairs to this and a number of bridges in this corridor. There's just another signal blown up of the area of concern. It matched very well with the patching that was done previously, but that did not stop the issue of the runoff, creating a void under the slab. So now focusing on approach slabs, we recently completed the scans and the processing for a number of structures, and here's just a diagram showing where we saw, again, the issue, where sloping issues right at the joint of the approach slab meets the pavement. I've heard some discussions here at the exhibits of different products you can use to seal that gap. that may help, but this particular one has some deeper settlement issues. As you can see here, here's the scans. Again, this is a slice. It can be done in a 3D model, but this one shows that down 3 feet where the blue line is, there's a significant interface where there's a change in material and settlement is occurring above the, this particular one happens to have MSE walls at the abutment, so you can see the reinforcing straps a little bit deeper in the diagram. Here's another one at an approach slab. Again, the diagram showing where the issues are, and again, the other diagram at the exit slab. You also can look into the approach slab or the pavement, and you can identify issues such as debonding with if there was different materials used in the design of the approach slab or the pavement. And you can also get a detail of the thickness of the approach slab if that met the specifications from the as-built, which a lot of these will surprise me. Maybe the design engineers aren't surprised by this, or the contractors, but the change in thicknesses of different features. And here's just another diagram of the 3D radar imagery showing the pavement thicknesses. In this particular slab in the upper corner here, there was actually a void identified, and we cored it earlier this week and found a 1.5-inch gap below the concrete approach slab. And this is what the surface looked like. You can see the cracks in the surface here that have propagated and are indicating an issue. Of course, the traffic knows there's an issue because there's a little bump at the end of the bridge. The lamination being identified in these approach slabs and separation from the rigid concrete approaches. A few more diagrams. We do the non-destructive testing, but that's not the end of it. You don't want to do one technique, geophysics, or whatever method you're using. I also have a core rig, and we identify based on the GPS of these locations that survey grade, the locations to follow up with coring operations. And this one's particularly in this interchange. We identified 8 cores, just zeroing in on exactly where you want to do it. So Expressway is a product that we use to view this data, any projects for the clients on the World Wide Web. So it's GIS based, and the client can go to the web and view the outputs from our reports. We also merge it with a mobile painting system to identify the features that you're seeing subsurface on the surface, so that you can come back and core them. If you were to sub that out, fortunately, I'm doing that internal to the company, so that's working out well. But you can also use the painter for other features in a bridge deck or a pavement investigation. We also have a downhole LiDAR tool to look down and actually visually measure the voids, and we're purchasing a downhole camera. So this is a diagram of the paint system. It's actually here in the exhibit hall. Here's the image of it. It's, again, survey grade, so that we can trigger above the feature that we want to core or the feature that needs to be further investigated. And here's just a little video. So they're just plain old paint cans. They're triggered at the GPS location, and all in a mobile operation, so nobody's out in harm's way. Here's our coring rig, and here's the downhole LiDAR tool that you can put down the core hole, and then the LiDAR head can be spun around to give you a 3D image of your subsurface issues. And that's my presentation, the approach lab investigations that we've done at iSee. Are there any questions? Yes? Yes. So far, we've only provided the service, but I can get with you later on a price for that. We've done it in a few locations for a couple $100 a site, but we can talk about that later.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.